In times like these, information is the most valuable resource. At Automotive News, we are deeply committed to keeping you informed, working around the clock in all mediums to deliver detailed reporting and analysis of the pandemic and its effect on our industry. Our coverage has been and will remain timely and vital. This is the time when journalism shines and the partnership with our readers endures. Automotive News is a resource you can depend on to navigate uncertain times. Subscribe today at autonews.com/subscribe.
Good morning, and thank you for joining us in the State of Manufacturing session at CAR MBS 2020. During the session, all audience members will be muted to ensure a quality user experience for everyone participating. Please submit your questions by using the Q&A function. If you have any other questions regarding the virtual MBS experience, please feel free to ask those questions at the information desk in the virtual lobby. Please also take a moment to visit the virtual exhibits in the exhibit hall. And if you would like to earn CEU or PDH credits for participating in CAR MBS, please visit our MBS page on our website at www.cargroup.org to access the registration link for CEUs or PDHs. Once again, thank you for joining us today. I'm pleased to welcome session moderator, CEO of Lyft, Nigel Francis.
So good morning, everybody, and welcome. Thank you very much for joining. Nigel Francis from Lyft. I would say that today we have an interesting session looking at the state of manufacturing. The session is billed as challenged by trade, technology and talent. Manufacturing is facing a remarkable transition. I would say that maybe also transformation comes to mind. So I'm lucky to be joined by three industry leaders here. So I'd like to introduce those three leaders that have been kind enough to come and impart to us their thoughts and wisdom on technology and talent in manufacturing in the US today. In no particular order, firstly, Hadrian Rory, who is the CTO at Lyft and a colleague of mine. Hadrian is standing in for Susan Smith from SME, who unfortunately is unable to join us this morning at short notice for a personal reason. Secondly, Raj Batra from Siemens. And thirdly, Harris Ng from Kearney. The way we're going to attack this today is I'm going to ask each of the speakers in turn to just say a few words, their thoughts on the state of manufacturing today. Clearly, COVID is on our mind. However, I would say that tomorrow at the same time, there is a panel session on reshoring. So to some extent, we're trying to keep on the technology and talent track here and leave the reshoring discussions until tomorrow. We've elected to make remarks and take a few questions sequentially. One speaker speaks, a few questions. Next speaker speaks, a few questions. Last speaker speaks, a few questions. And then we'll go into a discussion session amongst us all. I'm very much looking forward to that discussion session. So firstly then, I'd like to introduce my colleague Hadrian Rory. So as stated, Hadrian Rory is the Chief Technology Officer at Detroit-based Lyft, where manufacturing technology and talent matter, and one of the founding Manufacturing USA institutes. Hadrian is an accomplished executive with over 36 years of experience in product creation and quality improvement. Prior positions include Executive Vice President for Akebono Brake Corporation, responsible for North American engineering, quality and program management. In addition, he served as Vice President of Vehicle Engineering at Bright Automotive. Prior to Bright Automotive, Mr. Rory spent 24 years with Chrysler Corporation, where he held a variety of product engineering executive positions. His last role at Chrysler was Director of Chassis Engineering for body-on-frame products. I would say that we're lucky to have Mr. Rory to share his thoughts with us today, and clearly has been involved in manufacturing for a long time. Adrian, the floor's yours. Thank you.
Thank you, Nigel. A pleasure to be here this morning. Thanks also for the nice intro. So let me start off a little bit with my background. So Nigel mentioned that I've been one way or another involved in the auto industry for about 36 years. And I remember when I first started at a college, I think it was my first week, I got a tour of the old Chrysler Jefferson assembly plant. And if any of you have ever been there, it was quite a sight to behold. It was at that time building K cars. And I had never been in a noisier, dirtier, or just more unpleasant environment than being in that plant that first week out of college. And I remember there's got to be a better way. There's got to be a better way to build vehicles and build parts. And I think over the last 36 years, I've been spending a lot of my time trying to figure it out. I will say that really, at least in 34 of those 36 years, my goal has been, how do you make many of the same things exactly the same time and time again, right? How do you make a lot of the parts always the same, very little variation, always consistent and always high quality? And I've had varying amounts of success at being able to do that, but that's at least been the goal. Over the last couple of years, I've really kind of had my eyes opened in the world of additive manufacturing, and how really the goal is to make one of something extremely well. And I really think as I look at what's happened just over the last couple of years that I've been involved in some of the processes, it's really going to revolutionize manufacturing in the future. I think, what I've seen right now is that the technology is progressing really every day. It began with making fairly small plastic parts. Now you can make parts of any kind of material. You can make them in a myriad of different shapes and sizes, all the way up to very large structures. I don't know if everybody in the audience has seen some of the 3D printed houses, but if you haven't, a really neat thing is to Google search or go on YouTube and just search for 3D printed houses. And it is amazing how these large gantry 3D printers that are using concrete can make these really intricate housing and building structures. Very, very cool. I mean, huge, 50 feet long. So again, I really see that as kind of a wave of the future. Certainly there's some challenges, I think. Again, the challenge is, how do you make one thing that's perfect? And I really see some enabling technologies that come into play. One of which is really advanced analytical tools. So some of you may know of a tool called ICME, which stands for Integrated Computational Materials Engineering. And what that really does is it tries to understand how at the molecular level, how the material properties change as it's going through various processes, certainly through additive processes. For those of you that have ever designed or worked on welded structures in the past, you know that the heat affected zone is very, very critical. The material properties usually change, that it's very difficult to predict. Well, an additive part, especially when it's made of metallics, the whole darn thing is in a heat affected zone. So it's a rather challenge. It's a big challenge from a material property perspective. So a lot of these analytical tools need to really advance the state of the understanding of materials in order to really get additive processes to I think, take off. The other thing that's really important is again, you're making one of something in many cases. How do you know that you're making a good part? And I think what's really going to come into play is a lot of in situ inspection and really quality control techniques. So how do you look at a part while it's being made through video systems, through radiographic techniques, through other methods to understand that you're making a good part, that it's meeting your objectives from a material property perspective. And if it's not, how can you use AI to basically modify the process real time to make the thing that you want? So really, I think those are two very important key players in advancing additive technology, but I think they're happening. They're happening on a daily basis, and I think it's really going to push the technology forward in the future. And at this point, I'm already starting to see some of that. You know, I'm seeing that certainly there's applications in making tools for the auto industry, right? Whether it's dies or molds, patterns for castings, that sort of thing. 3D printing is used pretty significantly. I think there'll be an application, especially when you start talking about distributed manufacturing and point of use manufacturing, right? So you can make maybe bespoke parts that meet a very specific customer need, very specific duty cycle, environment, whatever, right where it's needed. I especially see that at LIFT, we do a number of projects with the Department of Defense. And when you think about needing that type of on-site manufacturing, you can't think of a greater need than in a war zone, right? Where you need to have a part. It's difficult to deal with logistically. You have to make it quick. You can't have downtime. And, you know, in those kind of applications, I think additive manufacturing is really going to take off in many, many different industries from where it is today. I also see a synergy with robotics. So think of how you can integrate a robot with a print head, and in the same cell, for instance, also use robots to subtractively manufacture and work on that same part. And also use a robot that has visual systems on it that can help you figure out how you're making the part. So all of that can be integrated into one cell, and you have not only additive processes, but subtractive processes and inspection processes all together. And, you know, we're not there yet. I think it's going to take a few years to really get the technology where it needs to be, get some of these enablers where they need to be. But it really is the wave of the future in many, many different cases. And I think certainly I'm going to be spending the next part of my career working on that technology. And I think we'll see more and more application of it throughout industry. And I really think it's going to be a big boon to the United States. I think it's going to help with onshoring, especially when you can make parts at point of use and you get rid of the whole logistics chain. I think will make a tremendous advancement in how we manufacture items in the US. So with that, thank you.
Hadrian, fascinating, and very, very much liked hearing that from you. I just remind everybody here that we're saving questions to the end, so I'm hoping that you're jotting down your questions so that we can have a good discussion at the end. I'd now like to introduce Raj Batra. Raj is President of Digital Industries for Siemens USA, where he oversees all development, marketing, sales, research and development, vertical industry and manufacturing aspects for digital industries in the United States. Raj is also a member of the Board of Directors for the Siemens Foundation. In 2019, Raj was appointed Chairman of the Board of Governors of the National Electrical Manufacturers Association, NEMA, an organisation responsible for guiding technical standards, providing advocacy for industrial policies in the areas of digitalisation and automation, and enabling the dissemination of crucial industry data. In addition, he serves as a member of the Executive Committee of Manufacturers Alliance for Productivity and Innovation, MAPI. Just as a reminder, Siemens Digital Industries is an innovation and technology leader in industrial automation and digitalization, and the driving force for the digital transformation in discrete and process industries. And I'm very glad that you're here to share your not only local, regional, but also your global experience, Raj. And we, of course, at LIFT are very pleased to be working with you on a number of advanced activities, not least of which is adding intelligence into the digital twinning loop. So Raj, thank you very much for your remarks.
Yeah, thank you. Thank you very much, Nigel. Thanks for the kind introduction there. A bit overly generous. But look, let me just start with this. We talk a lot about the national spotlight, which is shining a lot on America's aging infrastructure. Most people think of that, and you don't typically think of American manufacturing when you think of aging infrastructure. You think of dams, roads, and sometimes bridges. But the pandemic has changed a lot of this, and the public realizes that manufacturing infrastructure right now also needs an upgrade. We have an aging asset base in the country that is at the end of its useful life, so you simply can't get the productivity needed. With technology that's 30 plus years old. And if you think about, the fact that you have to change your iPhone every 6 months, it's not okay to have 30-year-old technology sitting in manufacturing environments that are really responsible for driving cutting edge productivity. So this aging asset base becomes a critical issue. We've seen some examples of this through the pandemic. Our response has been slow in producing PPE, testing supplies, ventilators, et cetera. The Defense Production Act was invoked. And even good luck finding some of that stuff today, right? So it just shows you the restocking of shelves and all the rest, just what a demand and strain it put on a supply chain. So also some of the oldest technology present in the United States is in our food and beverage plants. That's a very local business. We don't produce food and beverage products and then export them into the country. It's generally a very local business. It's also, believe it or not, the largest installed base of automation in the country. And if you look at, if you go back in COVID, I want to try to reflect this back on COVID. We saw the tragically high numbers of infections in meat processing plants, right? And I think we all heard about that. Part of that was the technology aspect. Part of that was the aging infrastructure. Part of that was just not having the right tools and sophistication and contact tracing and social distancing to be able to handle it. So some manufacturing plants are having a really tough time getting back to work safely and using social distancing and looking at high traffic areas and contact tracing. It's a problem that manufacturing companies are scrambling to solve very quickly. And actually the nation is scrambling to solve that very, very quickly. So I would just say the good news in all that is that there's technology that exists that's able to solve a lot of those problems. And some very progressive, smart companies are already using those. And here I'm talking about the intersection of the IT and OT environments and the intersection of digitalization and automation technologies. So if you think of what the pandemic did, a lot of companies were able to retool and change from existing products that they make today to producing an adjacent product. Or a completely new product, right? And this is where digitalization and flexibility plays such a critical role. And that helps in the pandemic response. So here I'm thinking about things like masks and of course, ventilators. Some companies have been able to meet the surge in demand, with these advanced technologies. Think about e-commerce. We saw more growth in e-commerce in 90 days than we saw in the last 10 years. And, if you think about warehouse automation, online grocery ordering, we saw a doubling in percentage of U.S. consumers that want to do a lot of this online, and even through the pandemic and post-pandemic, still want to do it online. And this means that consumer packaged goods companies and companies that really boomed in the crisis have to get smarter about their products, weight, packaging, production, the flexibility, what they're producing, what do consumers want. And so some are making big investments, even in the pre-pandemic time, and then that carry through the post-pandemic. So I think the takeaway in all that is digitalization is really the key and only path forward. It's the way where we're going to get ahead of the supply chain resiliency topic. It's the way we're going to be able to address stateside manufacturing. It's the way we're going to be able to produce high-tech, high-value goods with the kind of flexibility and customization we need and get to market very quickly, which is the greatest decisive advantage of having things on a digital backbone. So I guess in summary, I'd say, the silver lining of the pandemic, if there is one, is that good trends are accelerating. And, as modernization takes hold and you see companies like Tesla and Amazon and others that are doing things with digital technologies, others are certainly going to follow. And that technology, by the way, is not going to run itself. You need people to do it. And I think, as you rightly said, people are going to play a very critical role in how this transformation occurs here in the country. And we need young people to get interested in manufacturing again. And I think the pandemic and the spotlight we've seen just shows you how important and vital manufacturing is to our economy. And I think irrespective of what November yields, it's still going to be critically important to the economy. And you're going to see a renewed focus on manufacturing within the country, serving local demand. It's the safest manufacturing strategy that you can employ. So, the pandemic is tragic. It's strange to live through for all of us. Trust me, I have a couple of kids at home, and it's unleashed a level of creativity that some good, some bad, but a really good cooperative spirit. You see that in society at large, right? So it's created a compelling event for the country, for U.S. industry, and I'm optimistic that that things that were sort of on the back burners are going to get accelerated very rapidly. So maybe with that, Nigel, I'll hand it back over to you.
Hey, Raj, yeah, wonderful. And thank you very much for that. I'm sitting here and I'm thinking to myself, in my personal life, I know a number of people that have smaller manufacturing businesses. Every single one of them that I've run into over the last couple of months or talked to them, via text or email or whatever, they've all said that they're crazy busy. I think manufacturing is actually here, and we're going through a transition or a transformation, and I think the challenge is for us all to grab that opportunity in time to actually reinforce the manufacturing sector in the US. Anyway, hey, I should not be making too many comments here. Let me so thank you. So hope everybody's sticking with us here, and what we're now going to do is move on to Harris Ing. So Harris is a partner at Kearney, which is a global management consulting firm. He serves automotive and industrial OEM and supplier clients. His work focuses on corporate strategy and operations. He's been with the firm for 15 years, and prior to Kearney was in product development for 10 years for an automotive supplier. Harris is based out of Kearney's Detroit area office. I also recall that Harris is a graduate of Kettering University from memory. So Harris, very glad to have you here. Always enjoy discussing the intersection between strategy and operations with you, because strategy is great, but if you can't execute it, it's an academic exercise. And I know that you work in that space. So looking forward to hearing from you. Thank you, Harris.
Thank you, Nigel, and good morning, everyone. It's really amazing how much has changed in how we work and where we work in the past few months. And if you look at how we've adapted to COVID, it's really proof on how resilient we are, personally in the face of change. And you think about it, it's hard to believe it's already been 4.5 months that we've been living like this. So I think that's great that we've been proven to be this resilient. Just looking back a little bit further and winding the clock back, and if we think about the history of manufacturing and automotive, it really has evolved. 25 years ago, when I was just entering the auto industry in the mid-90s, right, that the top selling vehicles are cars. It was the Ford Taurus, it was the Toyota Camry. And if you remember back then, US OEMs were battling Toyota and Honda for market share. The OEMs were sitting there dealing with legacy costs, while many of the new players were kind of in the market with kind of an inherent cost advantage because they didn't have that legacy. NAFTA was just signed, so Mexico was just opening up in a big way. And if you think about this 25 years ago, the auto industry was really focused on reducing costs. And it was the mantra was back then, low-cost country sourcing, right? How do we find the lowest cost manufacturing to build these parts so that we can reduce the cost of the vehicle? So if you think back 25 years ago till now, auto imports to the US has grown 85%. Last year alone, 40% of our US auto content was imported. China went from less than 1% of our parts import to over 15% of our parts import in 25 years. And NAFTA also started in the mid-90s, and now Mexico accounts for half of our automotive employment in North America, making both parts and vehicles for the US market. So all that is to say that in the past 25 years, the industry itself has been really focused on labor arbitrage, right? How do we create these far-flung manufacturing and supply chains to find the lower labor costs? And now as we kind of enter the 2020s, we're kind of faced with a new set of challenges, right? So, and I think everyone knows them, right? It's the combination of the trade wars, the COVID, and now USMCA. All this will cause OEMs and suppliers to want to reduce the length of supply chains, simplify their manufacturing networks, and try to produce more locally. From a trade standpoint, right, we've seen a lot of, we've already seen shifts from China to other countries because of tariffs that started in 2018, early 19, and you'll probably see more diversification there. And if you remember, right, the COVID impact is really 3 different phases, right? If you can think back to February, it seems like a lifetime ago now, right? The whole industry was scrambling to identify, what suppliers are at risk, what parts are at risk in China, especially in the Hubei province, right? And that went on from February to mid-March. And then we did the broad shutdown, right? So at that point, everything was a different game. We're waiting it out. And then now, starting in June, once the plants restarted, right now the OEMs and suppliers are working really hard to keep this fragile supply chain together, supplying parts and keeping the plants running. And everyone's fearing, right? Shutdown of plants could be triggered in some faraway region if there's a resurgence of infections or whatever. It can put a hole in a supply chain and cause kind of a ripple effect that goes all the way up to the assembly plants. So those are the 3 phases of the COVID, right? And then we think back, even with the trade going on, with COVID going on, now we have USMCA also being implemented. That increases the North America labor content. It also increases labor rates. So that will also reshape kind of how OEMs and suppliers think about supply networks. So if we think about all this, the last 25 years, right, was really focused on labor arbitrage. How do we try to find the lowest labor cost around? Right. And if we think about the 2020s and going forward, I think the view is going to be the focus will change from labor arbitrage to really technology arbitrage. How do we use manufacturing technology to improve the labor productivity and reduce the labor cost and the overall cost so that we can create shorter supply chains, manufacture in higher labor cost areas, and really simplify our supply chain? Because that cost of risk is real for a complex supply chain. And all this takes investment, right? Raj talked about the aging assets and the fact that there hasn't been a lot of investment in a lot of our assets in the manufacturing base. In reality, we've had years of low cost capital, but in our industry, we have a lot of competing needs for capital in our industry, right? We have the autonomous, we have the EV, we have all this different product technology that's fighting for capital in our industry. So that's why the broad adoption of manufacturing technology won't be appropriate, right? I think us as manufacturers will have to find the right use of technology that drives the business cases for the improved conversion cost. We will have to be surgical about finding the right applications and use cases that have the highest returns on investment. So it's going to be labor productivity will be important, right? So we'll be looking at labor intensive processes. How do we use cobots to help line balancing by flexing work between operators and the cobot? Manufacturing quality has been and always will be more important, and it's even more important for cost from a reject or rework standpoint. So using AI or vision technologies to error-proof and find defects real time are going to be important. Hadrian talked about additive, and the additive impact of auto manufacturing will grow. So right now it's used a lot in customization, especially in luxury market, right? But as we think about, previously your real complex assemblies, those may be replaced by single piece additive structures, right? And just change how we design and manufacture. And then augmented reality, if you think about work instructions and worker aid for production and maintenance, right? Augmented reality is going to be a big benefit to manufacturing in the long term. So all that to say, our industry has to work hard to find the right technologies that can derive the real benefits. And the competitiveness of the industry in the next 25 years is really going to be determined by our ability to use the technology in the right places. And those places are the ones that create the productivity and the efficiency that we need to replace the labor arbitrage that we've had for the last 25 years. And really to do this, we have to get a few things right. The first is we have to be better at developing business cases for our investments, right? How do we prove that this is financially the right thing to do? I think that's been a struggle for a lot of manufacturing in the community. The next is allocating sufficient capital to operations. I think for a very product-driven industry, right, capital goes to the product, right? How do we get the latest technology parts out there? How do we get the latest technology vehicles, et cetera? And that is a fight for capital, and a lot of our manufacturing is really been lacking investment because of that. Ensuring that we grow talent in the workforce is going to be necessary for this new manufacturing environment, right? It's not the same kind of low skilled job assembly plants that we're talking about. It's going to be very, very much more higher skilled. And then I think the most important piece in terms of how to be ready for this is that we have to be ready for change on all sides. And that really means that our manufacturing technicians have to be able to speak the business, right, and the investment and the payback that's required. And then our business leaders really need to focus on the manufactured technology in what is historically a product-driven business. So all of those are important for us to kind of get this move from labor arbitrage over to technology arbitrage and really use technology to drive kind of the next wave of competitiveness. So with that, I'll turn back to you, Nigel. Thank you.
Harris, thanks very much. And that was a very good segue into maybe a couple of comments from me. I've been lucky enough to spend time with both Fortune 500 C-suite through the billion-dollar range manufacturing companies right down to the mum and pop shops that actually drive this nation's manufacturing base forward, the people that are making things. And, I think what I see in my current role is that generally the Fortune 500 companies have got a good handle on what to do. People below that are in various states of organization or disorganization. And I see a lot of fear in the smaller organizations. They don't understand what they know. They understand that there is a transformation and a transition necessary for them to remain competitive. And indeed, what we should all be doing is trying to increase our competitiveness on a global basis. It's not about staying where we are. It's about increasing the height of the bar. And what they need is they need trusted advisors. They need people that they can actually go to, and those people need to be pragmatic. They need to put solutions that are deployable within the constraints that you just discussed, which is, there's a talent issue. You've got to have the right people to be able to deploy those pragmatic solutions. There's also a capital issue. The solutions are not free. I think that the industry base is working very hard to keep the solutions within reasonable costs, but there needs to be a good business case. To me, it's about technology, talent, and capital. And I think we all understand that here. So hey, I just want to sort of starting the question, the question and answer of or the discussion session, if you like. Harris, starting with you. So, what advice have you got for a tier 1 supplier, for example? I mean, what should a generic tier 1 supplier be thinking about right now?
Yeah, I think a couple things. One is really rethink your footprint, right? And I think a lot of tier 1 suppliers end up with a legacy footprint, kind of legacy plants, and they kind of build their product based on kind of their old footprint. And I think with all the changes going on in the industry in terms of where volume is in the world, what's going on with the trade, the tariffs, the complex supply chain, we really have to revisit our footprint, understand both the supply network and your manufacturing network, and make sure that they're ready to supply kind of more local as much as possible and try to be as competitive as much as possible. And whether that's a combination of ultra efficiency on the plant floor through the use of technology, or maybe just revisiting the structural cost, challenging those assumptions that I think we all have in terms of, what cost levels are in which regions of the world. And I think that's what has to happen before, everyone goes out and starts looking at the next program and figure out where to build it. Because I think at that point, it's a little bit too late to really challenge assumptions. By then you're kind of reacting to program packages and trying to understand, just how best to competitively quote it in that sourcing process. So you really should be getting ahead of that and trying to understand kind of what's the right footprint for my customer base and where they manufacture vehicles. And then how do we make sure we challenge all those cost structure assumptions?
Yeah. Yeah, so Raj, digitalization is obviously critically important here. I think, we're all on the same page that we need to stop trying to squeeze another 25 cents out of the system by pushing down on labor, and we need to focus on, get back to basics and look at improving holistically the manufacturing process efficiencies. Can you give us your thoughts on digitalization in the manufacturing world going forward, please?
Yeah, sure. Look, it's how I preface my comments that the good trends are really accelerating right now. And, if you go back to our history, if I just spend a couple of minutes on that, we've been at digitalization as a topic for decades, right? And so we made a major acquisition in 2007 of a company called UGS. And the focus of that was to really marry the ideation, design, and development process of products with the manufacturing processes. And I think that, the adages have been around in industry for a long time. 80% of manufacturing costs are predetermined in the product design phase. So if you don't get the design right and you're not designing right, you're not manufacturing right. So it's critical to have a digital continuum of the design and manufacturing processes. And when these are in a common model, right, you have a common digital backbone where you can model and simulate these things. You really get incredible productivity in time to market, in reduced engineering costs, in doing flexible combinations, buildable combinations of products, dealing with different types of consumer demand. So it's very relevant to all industries. So those acquisitions we made back in 2007, we made about 10 billion euros of acquisitions in a multitude of software companies. It was really all designed to build what we call a very holistic digital twin. And that holistic digital twin means that we want to be able to simulate things in the virtual world before we do anything physically in the real world. And that simulation in digital twin means a digital twin of the product itself, of the production or manufacturing process, and also the performance of the process. So how's the process running? Where do you optimize? Where do you enhance? And how do you do all this in a virtual way, before you put physical assets on the floor and before you do physical work? And quite frankly, we've been used to doing it the other way around. And so this is going to be one great productivity enhancement that digitalization brings. If I just bring this into the COVID world, about what simulation does. Today manufacturers are really facing challenges. They're looking to restart operations. As I mentioned earlier in my talk, they want to maintain their operations during the pandemic. They're looking at the next normal, and they have to look at employee safety, look at establishing the right distancing in production environments. So simulation, just as a topic, has really been critical there, because we can, with simulation tools, look at people's movement, look at physical distancing, look at how to approach things safely when you're restarting a manufacturing plant. And so part of that is simulating and contact tracing, and part of that is really validating now with real hardware and real technology. So we're using transponders and tags that are typically used in manufacturing environments for assets, but we're attaching those to humans. And so we're able to simulate the environment and look at the workplace dynamics with simulation. And then we're able to use real hardware technology to be able to implement this, and you marry those together with some algorithms, and you really get this capability of social distancing, using simulation, using the next normal hardware technologies, and also employing contact tracing. So it's just a very relevant example in today's day as to where simulation and validation are used. And pre-COVID-19, this was used in ideating products. This was used in producing buildable combinations of any type of product in any lot size. And I think this is where digitalization is going to play a critically important role as we really move through the pandemic and emerge out of it. So it's going to get accelerated.
Yeah, and I'll sort of thank you for that. Just throwing in my own comments. Some of you know that I'm blessed to be able to interface on a national level with both the advanced manufacturing community, but also our Department of Defense. And it's very clear that a strong manufacturing economy drives a strong national security. And I'm not wishing to pontificate too much, but I believe that one of the top challenges and imperatives for the US is to embrace machine learning and digitalization of manufacturing, because at least to me, with the data that I have available to me and the vision that I'm able to enjoy from my current role, it seems to be the logical way of increasing the competitiveness of US manufacturing. So Hadrian, when you were speaking earlier, you were talking a little bit about additive manufacturing. So hey, are there barriers to embracement of additive manufacturing? I mean, it's hyped up a lot. I think it's very, very powerful technique, process, if you like. Barriers and, where next? And I'd encourage the other colleagues to jump in when Hadrian said a few words as well, please.
Yeah, that's a great question. I think one of the barriers I see kind of dovetails with both what Raj and Harris have been talking about. I mean, if you think of some of these new technologies, at the end of the day, you still need people to flip the switch, right, on all of these things. And workforce development, I think, is a hugely important challenge and task, especially as we look at some of these technologies. So I think really, some of the digital tools that Raj was talking about, and this can be especially true for small and medium manufacturers, they could use a lot of those tools to really help train the future technician, right, and associate. And in the past, you would have to have experts come in and talk to you about new technology. Well, now you can use augmented reality, and you can have really training lessons virtually, right? And you can train a staff with expertise that a small company would never be able to tap into in the past. And I think that's that's going to be a challenge, especially in adoption of some of these new technologies. If we don't have the workforce to be able to run them, they're not going to work. So that's a very important part of how I think we can leverage a lot of the digital tools in really helping to train workforce and improving really the implementation of some of the new technologies.
Yeah, hey, very good. And I think that's a critical thought tonight. So let me be provocative here. So we've got this big talent problem. I think everybody understands, right? Okay, so why is an industry jumping in with both feet and actually embracing that by funding it? Funding the filling of the training for it, because it doesn't seem that, it seems that industry is somewhat reluctant to jump in and solve one of the problems that's actually holding it back. Deliberately provocative. And everybody's being told not to answer provocative questions. So Harris, come on, I'm going to put you.
No, I can, I'll take a run at that question. You know, I think there's two things going on, especially in our industry, right? There's, when we think about manufacturing technology and talent, right, there's, it really, there's a kind of a pull towards kind of college education, towards, you know, kind of office jobs. And I think that that's been happening for the last decade. That really, I think, makes the idea of manufacturing jobs, you know, semi-skilled jobs, where you're, you know, dealing with technology every day on the plant floor. Those type of semi-skilled jobs aren't as kind of promising out there for people, right? Versus other countries, and I think Germany is always the one that's used as kind of the model, right? And Raj, being from Siemens, knowing the German, you know, culture, you know, very much around apprenticeship, around kind of teaching technology, both at all different levels, whether you're kind of working on the plant floor or working in the office doing manufacturing, you know, design and development, right? So I think that's one piece of it. I think the other thing is, as an industry, we also have an overall technology problem, because, you know, aside from, you put aside Tesla, right, there's not a lot of people that are dying to go into kind of an older manufacturing industry. You know, I think us as an industry have to make it more promising, more kind of exciting for people to come into. You know, I think our auto industry is, we don't like change, right? In fact, change is bad in manufacturing, right? Because it can cause quality problems or kind of surprises on the plant floor that maybe, you know, manufacturing people don't want, right? Hadrian talks about that perfect part, right? Everyone wants that perfect part and repeat it all the time, right? That's the exact opposite of change. And I think that, so if you put all that together, I think culturally, the auto industry doesn't attract a lot of the exciting new talent that's coming out. And, you know, we have to change our culture in order to be able to excite people to come to the industry.
Yeah, I think
Well, let me,
go ahead, Raj.
no, I was just going to add a comment to that, Nigel. And, you know, to Harris's point, I think, you know, we have to be fair. I mean, manufacturing recently is becoming more strategic to the enterprise. For all that we talk about with reshoring, with more stateside manufacturing, with doing more things in the country, with having better supply chain resiliency. You know, it just wasn't a place 20 or 30 years ago that you found a lot of people aspiring to go to. You know, they thought it was a dirty, grungy job. It was your sort of grandfather's manufacturing. These are highly sophisticated environments, replete with the latest technology. And I think, you know, look, we have a big crew change underway, right? So the largest boomer cohort, so I guess those born in 57 are going to be 65 in just 3 years. If you think about it, you know, most of those people would largely be retired had 2008 not hit. And now, of course, COVID hit, which could even accelerate some of that very, very quickly. And now you're bringing a whole different generation in that has a set of experiences that are critically important to industry. And I call it the big crew change, because some people say, well, you know, that's a big brain drain. It's true. You know, you're losing a lot of tribal knowledge. But look, these are people coming in this millennial era that never knew a world without the internet, never knew the world without a smartphone, fully understand apps. They don't get an instruction book when they get their iPad. So it's really critical that they bring this kind of capability and technology into the manufacturing discipline. As we think about digitalization, you think about marrying design and design and production together, and the great gains this gives you. You know, this is really done in a, you know, you can do a lot of this in a simulated environment, you know, before you get down to the floor.
Yeah.
And so it's things they naturally do, and things that are very, very critical. But this technology is not going to run on its own. So there has to be a stimulus. Parents have to be involved, and this has to start early, right? And so things that I always think of doing. This is not something you start when someone's in college. You're stimulating interest really at the high school levels. You're deploying technology in educational institutions. You're providing in-kind software grants. So when these kids hit the manufacturing environment, and when they arrive in a company, they're not on a 4 or 5 year learning curve as to how to use the technology. They're already adept and proficient at really using it. And then they bring creativity, their own ideas, and that takes a life of its own.
Gentlemen, audience, I've been reminded that we're 1 minute over already. You see the passion in the, in the eyes and the words of the colleagues here. What I would say, just to round out what Raj was saying, was I think it's incumbent on all of us to remind the general public and people that might want to come into the automotive industry in particular, that we are producing one of the most complex consumer products that's possible to make, that's expected to be perfect every minute of every day of every month of every year for years and years and years, with seamless operation. And it's got tens of thousands of parts and millions of lines of software code in it. It's really, really interesting work, and it's clean and clever, not dull, dirty, and dangerous. So look, I'd like to thank the panelists for joining me today. I'm eternally grateful for your time, your energy, your passion, and your wisdom. And I'd like to thank all the attendees for attending this session. So thank you to everybody, and please stay safe and well, and keep moving US manufacturing forward. Thank you.
Thanks a lot, Nigel. Take care.
Thank you, Nigel.
Thank you, Nigel.